Welcome to our practical video session on problem solving in real and cubic expansivity of liquids. In this lesson, we are going to break down an exam-style question step by step so you can see exactly how liquids and their containers expand together in harmony. Let's read our question carefully. A glass flask of volume 1000 cubic centimeters filled with mercury is heated from 30 degrees centigrade to 80 degrees centigrade. If the cubic expansivity of glass and mercury are 2.4 times 10 to the power of -5 per Kelvin and 1.8 times 10 to the power of -4 per Kelvin respectively, find the apparent increase in the volume of the mercury. To solve this cleanly, our first step is always to extract the parameters given to us in the problem statement. We have an initial volume of 1000 cubic centimeters. Our initial temperature is 30 degrees centigrade and our final temperature is 80 degrees centigrade. Finally, we write down our two separate cubic expansivity constants. Gamma glass is 2.4 times 10 to the power of -5 per Kelvin. And gamma mercury is 1.8 times 10 to the power of -4 per Kelvin. Next, we need to know exactly how much thermal energy changed the state of our system. The temperature rose from 30 degrees up to 80 degrees centigrade. By calculating our delta T, which is final temperature minus initial temperature, we perform 80 minus 30, giving us a total temperature change of 50 centigrade or Celsius. Now we apply our relationship rule. Real expansivity equals apparent expansivity plus container expansivity. Since we are looking for the apparent value, we must isolate gamma apparent by subtracting the container's expansivity from the real expansivity of the liquid. Let's align our scientific notation values. 1.8 times 10 to the power of -4 minus 0.24 times 10 to the power of -4 leaves us with an apparent cubic expansivity of 1.56 times 10 to the power of -4 per Kelvin. Finally, we can calculate the actual visible increase in the liquid level. The formula for apparent change in volume is gamma apparent multiplied by the original volume multiplied by delta T. When we substitute our values, 1.56 times 10 to the power of -4 times 1000 times 50, we get exactly 7.8 cubic centimeters. Remember this critical exam warning. Your worksheet options list 9.0 cubic centimeters as option C. That value only tracks the absolute real expansion of the mercury if it were in a fixed container that didn't move. In a proper practical calculation, always make sure to deduct the flask expansion to get the accurate apparent result.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.